Good morning, everyone. How are you? It's okay. There's no need for audience participation yet. It's early. We're fine. Thank you very much for inviting me to be here. It already sounds after one speaker like I have found my spiritual home. I'm a geek. I'm a nerd. I am the love child of Star Trek and Star Wars. Yes, I like them both equally. It's okay. And this is a story that is pure science fiction. So to be able to not only tell you a bit about the story, but actually be part of it, for me is an absolute thrill. You're probably going to hear a lot of ideas over the next couple of days by the sounds of things that are moonshots. And what we mean by that is big, audacious ideas, like, for example, landing on the moon in the next 10 years, when you barely have a space program. And the reason moonshots are important is that they look to change the world by a factor of 10. It's not iterative. It doesn't change it by 10%. We look to change by much more than that. But that's not done by just working harder. We need bigger, bolder ideas if we're going to change the world to that degree. And why do we need to do that? Well, at the moment, we have a lot of challenges in the world. As you heard from Mike, population is going to be 8 million by 2023 and nearly 10 million by 2050. And the infrastructure, the transport systems we have around the world were not built to cope with those numbers. So to give you an idea, in the center of that picture, you see the Dubai Metro. It's the world's longest autonomous railway. It was commissioned less than 10 years ago. It started running in 2009. It is already over capacity at peak times. That is a 10% improvement on transport. We're not going to be able to keep the world moving if those are the type of changes we look to make. The other challenge we have is that the transport we use today uses a massive amount of energy, and it creates an incredible problem in terms of pollution. So we need different ideas. It's not going to change if we just make things a little better, a slightly better plane engine, slightly better cars. That's not going to help us. And that's very much where Virgin Hyperloop 1 comes in. We're going to try and do something very different, eliminate boundaries of time and distance, move people faster, and look at the possibilities and opportunities that happen when we do that. You've probably heard about Hyperloop and various billionaires, as you heard from Mike. Hyperloop is associated with Elon Musk because in 2013 he released a white paper called Hyperloop Alpha. And it was the first time anyone tried to put some maths and physics around this idea. As a transport goes, as transport through a tube goes, the idea's been around about 150 years in various incarnations. But Musk tried to figure some of this out, didn't start building it, and Hyperloop 1 did. We thought we'd have a go at making that happen. So my boss isn't Elon Musk. He's not WhatsApping me late on the weekends. Our chairman now is Richard Branson. We've recently rebranded, and Richard Branson has joined the board. But the important thing, this is a 5-year-old industry. There are no definitions yet. There are no standards yet. We are still inventing this transportation. So I'm going to talk you through what our idea of a Hyperloop is. That may not be what it looks like in the future. It's just what we think it is right now. So you take a tube, like an oil pipeline, a little bit wider. And in that you have a pod, which carries passengers or cargo. It's pressurized, like a plane, so nothing unusual there. But what we do is we pull all of the air out of the tube, so it's low pressure. It's near vacuum. The reason for doing that is the same reason we fly planes 6 miles in the sky. It's because there's less air there, and less air means you can travel faster and farther using less energy. We have a form of electromagnetic propulsion, and we combine that with magnetic levitation, which Asia is very familiar with in terms of bullet trains. Again, that means there is no wheel on track, there is no steel on steel, and that means there is no resistance, there's no friction. And combining this, we have an autonomous control system. The biggest cause of death in transport is human error, so we eliminate that altogether. So you've got no air resistance and you've got no friction from a rail, so how fast can you go through this tube? It turns out you can go pretty quickly, near the speed of sound, faster than a commercial airliner. And this would be through a tube, on the ground, on pylons, or through a tunnel. That sounds ridiculous. What does that mean in terms of speed? Well, if we look at one of the busier air corridors in the world, it means you can get places pretty quickly. Speed's the feature. What are the other benefits? Well, for one thing, you wouldn't have timetables or schedules anymore. Because these pods are traveling so quickly, the distance between them is great, even after a short period. So you can send multiple pods down a tube, even in a minute. So when you turn up, there is a pod there ready for you to go. We're working, a lot of this is theoretical, by the way. I'm not building it. I'm not even the driver. So I talk in hypotheticals a lot right now. We think we've come up with a way of doing branching, so essentially junctions off a tube at high speed with no moving parts, so that your first stop on the Hyperloop would be your final destination. And whenever we think about Hyperloop, we think about how we connect it to existing modes of transport, even either physically, in terms of airports or train stations, or how we'd integrate it into apps like Uber. Other benefits. When you're driving a car, it's called an accelerator, but you have to keep it pressed down constantly to move at the same speed. And that's because you have friction between the road and the wheels of the car. That's not going to happen in a Hyperloop. It's essentially floating, which means once it's accelerated to speed, it can continue at that speed without additional power for, we think, 25 or 30 kilometers. There are no direct emissions. There is no exhaust pipe. This could be fueled entirely off renewable energy. As I mentioned, a low physical footprint. We see this working on pylons or through the ground, through tunneling. And there's no noise. This is a spaceship. It is floating in a tube, traveling at near the speed of sound. It doesn't make any noise. Now, you're all saying, Paul, that sounds like a brilliant idea. But it sounds like that kid who loves Star Trek and Star Wars equally is just dreaming. It's some fantasy of when he's 7-year-old and watching Star Wars for the 84th time. Is it real? Well, to paraphrase John Lennon, I may be a dreamer, but I'm not the only one. There's actually about 300 of us trying to make this happen. And they are some of the smartest, most brilliant engineers in the world. Some of them, in fact, responsible for making that reusable rocket land on an autonomous drone platform at sea, which now we're quite bored to see every month, but actually is still a pretty incredible kind of thing. Oh, and we've built one as well. This is our test track called DevLoop. This is in the Nevada desert, and we started running pods through there last summer. They're now traveling at nearly 400 kilometers an hour, which doesn't sound that quick, but the point of this test track was to test integration. The physics of vacuums and maglev are pretty well known, but what we needed to do was check if we can use maglev, electromagnetic propulsion, on a pod, in a vacuum, in a tube. And we did. So I'd just like to show you a quick video. It combines some of the footage of some of those test runs with some animation to give you an idea of what we think a Hyperloop looks like.
All right, all parties ready for tests? All right, firing in 5, 4, 3, 2, 1. Fire.
So that's what a Hyperloop looks like. Now, we've done a lot more since then. It now has an airlock, which is very exciting. We're going faster and faster every day, but there is still a lot of work to do. We don't think the challenges are necessarily about technology. There's some around design. The biggest challenges are probably going to be about regulation. Can we find a government somewhere in the world that wants to sit down and work on this with us and make it reality? What happens if we do, though? How does that change how the world works? Well, if you look somewhere like the state of Maharashtra in India, what if we can take the centers of the financial center and the industrial center and link it to the IT center and engineering center? What happens then? We create this mega city where people can move freely between two places. And as you see in Singapore, once you get that density, some really exciting things start to happen. If you were an employee, where would you work if you could commute 10 times further? If you were a business and you could trade without any barriers to your time and distance, where would you go? Who would you hire if distance wasn't an issue? It changes everything about how cities and regions and countries work. And that's not just the only idea in India. We've actually signed MOUs with 3 states now. And the idea is, the bigger thinking, is linking this up so you can travel anywhere in India in under 2 hours. Another big idea is travel involving airports. And as we talked about, airlines have some incredible challenges coming. They have to halve their emissions by 2050 just to cope with the increase in passenger demand, and that's going to be massive, especially in this part of the world as the middle classes have more and more access to flights, to commercial flights. Airports are at breaking point, not just in terms of their infrastructure, but being able to meet things like the Paris Accords and make sure they're not going to continuously pollute the planet. So how can Hyperloop help that? Well, there's a couple of ways. One thing is we could actually save airports from building more infrastructure. We can take an existing airport and link it to an airfield 50 kilometers away. And we're looking at that in other parts of the world, taking major airports that are near capacity and linking them to former military airfields, which have permission to run commercial flights. The challenge is they're 50 or 60 kilometers away, which happens to be the low end of the sweet spot for what we think a Hyperloop can service. Another idea is connecting city centers to airports. We could build them potentially further away outside the city and reduce congestion and traffic. That's something we could look at in Singapore. And we've had conversations here as well with the Singapore government. If that still sounds ludicrous, just look what happens if we try to do this. Just by embracing the potential for R&D and developing this, over time, as we build projects, it knocks onto every other industry. If you think about the space program or think about the aviation industry, the benefits that has given us in terms of material science, engineering, the space program in medicine, just by trying this, things change. Private companies get involved, create R&D, jobs are created, things get better just by attempting this. This is Kitty Hawk in North Carolina in 1903. That is a man strapped to an engine. Slightly ludicrous idea then. That is the first manned flight by the Wright brothers. That flight traveled 121 feet, about 40 meters, and it lasted 12 seconds. I wouldn't have thought many of you would sign up for a trip on that. But 115 years later, look at what aviation has done to the world now. Look at what's changed. Hyperloop, I think, as a geek and a nerd, has that potential. There's a lot of risk, but it could change the world. So the question really in all of this isn't, will it work? The question really is, what happens if we try? Thank you very much.